So let's start now. So good morning again, everyone. I hope that you're all doing well. And I'm very happy to be here today to do this last session out of the 4 on statistics. And today we will look at energy prices and taxes and also energy efficiency indicators. So after having looked at the different energy commodities, energy balances, CO2 emissions, so this is one step further into looking at indicators. So again, this is just a reminder of the agenda. So today we are looking at the 4th statistics webinar. And as from tomorrow, you will start with the modeling sessions. So there will be 6 modeling sessions every day from now on. And then we will end up with the SDG and wrap-up quiz. But before we start with the technical part, let's just a quick reminder of the virtual, of the housekeeping rules. So the whole session is in virtual. If you have any questions, just drop it in the Q&A box. And at the end of each presentation, there will be a question and answer session where I will be joined by experts on energy prices and also on energy efficiency indicators to answer any question you might have. If you have any urgent clarification, you can also raise your hand. And also, if you have any other additional question, do not hesitate to write to me, to Arnaud, or to the Africa program mailbox. So now let's get started with energy prices. So for energy prices, the presentation will be divided into 3 parts. First, we will see why energy prices are important. Then we will look at the different statistical concepts on for energy prices and also at comparability. And then there will be a small exercise on prices. Before we start with the presentation, let's do a quick Menti. So I will share my screen again. So please connect to www.menti.com and use the code that appears on the screen, which is 70 49 34 and 04. So connect to menti.com and use the code 70 49 34 and 04. And the first question is, what are the different components in the end user price paid by the consumer for energy commodities, such as electricity and natural gas? So this is an open-ended question. Think about electricity and natural gas and what makes up for the end user price that the consumer pays. So what are the different components in the end user price paid by the consumer for energy commodities such as electricity and natural gas? So here you have to write down what you think. Production cost. We have a first answer that arrived. Demand charges, consumption tax. Yeah. So what makes up for the end user prices? Levies, service charges, consumption, profit margin. So we have more and more answers getting in. Delivery cost, very good. Fuel cost, marginal cost. Transportation cost, yeah. So there are many costs. Emission costs, yes. For some fuels, there are some emission costs now. Transmission for electric, yes. Environmental cost, yes. See operation and maintenance. So excellent. I think we have a view of the different components that make for the price, and during the presentation we will talk quite extensively on the different components of the energy prices. So next question is, are you aware of price data tracking in your country? So yes or no, do you know if in your country there is price data tracking? So we have a few that says that there is price data tracking, but some participants are not aware of it. Okay, so this is something we can dig later on with when we will start having bilateral on prices with the people who work on prices. It would be interesting to know what are the different institutions collecting prices data in the country. Next question, do prices data feed the policy work in your country? So I have a question in the chat box about someone asking how to put the response on the questions being asked. So you have to connect using your phone or your computer to the website www.menti.com. And then when you are on the website, you have to insert the specific code that appears on the screen, which is 70, 49, 34, and 04. And it's an interactive tool where you put your answers and we can see live on the screen the different answers that are arriving. So for those who have not yet used Menti website, it's very easy and user-friendly. So regarding the question, do prices data feed the policy work in your country? Most of you think yes, which is excellent. And only 1% does not think so, that it feeds the work. Let's look at next question now. So who is responsible for the prices, for the price data collection in your country? So here we are interested in knowing about the institutions that collect prices in your country. A few of you had replied previously that you know that there is a prices data collection. So who are the different institutions that do this work? So we have ZESCO, ERB, Namibia Statistics Agency, Central Statistics, energy regulators. Bank of Zambia, CSA. Ministry of Natural Resources, Eswati Energy Regulator, Excellent. So we have a few institutions that are doing this work. We have a few more that are getting in. ESCOM. Very good. I think we have one last questions. Yes. So what are the challenges for prices data collection in your country? So are you aware of some difficulties, challenges that institutions face when collecting prices in your country? So right, tell us if you know of no resources. Yes, this is a bit in many ministries and all. Sometimes there's a lack of resources to do surveys and to collect prices. Are there other challenges? No resources, lack of capacity, lack of cooperation. Indeed, sometimes even if you have all the goodwill to collect the prices, but if on the other side there's no cooperation from the different stakeholders, then it doesn't work. Clear legal framework. Indeed, if there's no legal framework that allows to collect that prices information, doesn't help. Human resources, yes, sometimes lack of staff, missing data, political influence, confidentiality issues. Very interesting. Percent, non-availability of data, lack of advanced tools. Very good. So we see there are many challenges in the data collection, whether it is for energy statistics or for prices. It's more or less the same challenges whenever you're collecting any data. Excellent. So now let's get started with the presentation.
Why are energy prices important? Energy prices are important because they affect our lives as consumers and the competitiveness of a private enterprise and therefore the economy of our country. End users' energy prices are influenced by price movements in the raw commodity markets. For instance, crude oil spot price market. The international spot price market is in turn affected to major events such as economic developments or even natural disasters. In the graph, we can see the step price decreases caused by global financial crisis in 2008, 2009, and the oversupply in the market in year 2014. More recently, we can see the effect of the COVID pandemic on the market, with the reduction of the price linked to the reduction of the consumption. But the cost of the raw material and the international markets doesn't capture the full story. In fact, the end-use price paid by consumers is subject to taxation that might represent the major share of the final prices. Why do governments tax energy commodities? The taxation of energy products may pursue different objectives. The first objective could be public revenue generation. In the short, medium term, energy demand is relatively inelastic, making energy products good targets for revenue generation. Another objective could be internalizing the environmental and health costs associated to emissions or other types of pollution. The third objective of taxation is to drive the change. High taxation on the most polluting fossil fuels can help shift consumption towards a less polluting and therefore less taxed energy commodities. Tracking energy prices is important also because they represent a significant share of our daily lives expenditures. For households, for example, the direct expenditure on energy might represent up to 17% of the household spending. The same can be applied to industry. Industry competitiveness is greatly affected by energy costs. This is true especially for energy-intensive processes, such as aluminum production, for which energy costs can represent around 40% of the production costs. For all those reasons, it is very important to track energy prices in our country and to have an international methodology that allows us to compare prices across the world. Here at the IEA, we track energy prices across the world in the Energy Prices database. The map on this slide shows gasoline prices across the world drawn from this database. An accurate database is the basis for conducting accurate and robust analysis on the energy scenario and for assessing the competitiveness of a country. Such data also allows for evidence-based policymaking and energy transition planning. Robust data allow to draw comparison to regional differences. For example, thanks to this dataset, we can say that consumers in Africa pays on average the gasoline 30% less than the average of the world and 50% less than European consumers. This dataset enables also further analysis such as the one showed with this graph. This graph illustrates gasoline price levels across countries based on GDP per capita, and it is taken from the IEA commentary on gasoline prices across the world. In this graph, we see that price levels are, in most countries, linked to the economic conjuncture of the country itself. Based on GDP per capita, we can identify 4 clusters of countries. Many developing countries fall in the cluster at the bottom left of the graph, since their governments often keep prices low to increase energy access. Please feel free to refer to the IEA commentary for further information and analysis on this topic. As mentioned before, it is important to have a common methodology for tracking energy price. This allows to have a solid international benchmark and comparable data. So let's now turn to the IEA methodology, which provides for such a common methodology and which has been adopted and used by other international organizations. End-use energy price is the sum of 2 subcomponents: ex-tax price and taxation, which is the sum of value-added tax and excise taxation. Having information on these components allows us to have a more solid understanding of the situation in the country and to draw policy implication and guide policy making. The ex-tax price includes all the costs incurred for producing the final product throughout the supply chain, except taxes. This includes the cost of raw materials, manufacturing costs, distribution costs, and profit. The excise taxation, instead, is generally levied on a volume basis and excludes the VAT component. This taxation might have different policy objectives and includes CO2 taxes, other environmental taxes, motor fuel taxes, emergency stock fees, and any other taxation applied to the commodity. And the last component is the VAT taxation. VAT taxation is a consumption tax on value added, and it is generally applied to the sum of the ex-tax price and excise taxation. As of 2020, over 170 countries had VAT or an equivalent taxes in place. To better understand each of those price components and how these can affect the end user price, let's have a look at a simple example of two hypothetical countries, A and B. Country A and country B have two different ex-tax prices for gasoline. This may depend on the different relative scarcity of the oil resources in the two countries or on different refinery and distribution costs. The government in country A decided to implement a lower excise taxation compared to country B, maybe to compensate the high ex-tax price. Country A has also a lower VAT rate compared to country B. So overall, the total taxation on gasoline in country A is lower than in country B. If we apply the VAT rate to the sum of the ex-tax and excise taxation, we obtain the VAT amount, which is summed to the excise tax, gives us the total taxation for fuel. As mentioned, the total taxation in country A is lower than the one in country B, and this makes the end user price lower despite the higher costs along the supply chain. Now let's delve into the methodology to calculate representative end user prices. What is the representative price for a country? Energy prices may vary across regions and provinces of the same country. For example, this map shows more expensive gasoline prices in the western parts of the United States compared to the prices in the southeastern states. Again, using an example may help better understand. Let's consider a country, which we will call Statisland, with two provinces, Eastern Statisland and Western Statisland. In Eastern Statisland, the price of diesel is $0.5 per liter, while in Western Statisland, gasoline is more expensive at $1 per liter. Diesel consumption is 500 kiloliters in the Eastern Statisland and just 100 kiloliters in the Western Statisland. If we calculated the simple arithmetical average of the two prices, we would have a $0.75 per liter. Is this a representative price? The answer is no, because as we can see from the input data, consumption is 5 times higher in the region with the lower price. Therefore, if we were to compute the simple average, we would not take into account this difference in consumption. In order to calculate a representative price, we need to weigh prices by consumption. If we take consumption into account, we obtain $0.558 per liter, which is the representative price for the country. When calculating a representative price, another important concept is the difference between prices and tariffs. In the data collection undertaken for our data tracking, we are interested in the prices, namely the average rate per unit actually paid by the consumers, no matter what is the price structure for the commodity in the country. Again, let's take a look at an example, this time on electricity prices. We all know that in general, the electricity bill has two components, fixed charges and the variable charges. The fixed charges pay for the connection to the grid, and it is not linked to the energy consumption. The variable component, on the contrary, is based on the quantity of energy consumed each month. In this case, to calculate the representative end user price for a user, we need to calculate the total electricity bill and divide it by the energy consumed. The total bill is the sum of fixed charges, 10 euros in this case, and the variable charges, which are 0.1 euros per kilowatt hour times 150 kilowatt hours. The total paid is 25 euros. The total now should be divided by the energy consumed, which is again 150 kilowatt hour. This gives the representative price for this consumer, which is 0.17 euros per kilowatt hour. To conclude, energy is an important component of our lives and for the economic development of our countries. And energy is a significant expenditure for our budgets. A solid energy price tracking system, one that allows having comprehensive and comparable data, is a key requirement for evidence-based policymaking and policy choices to increase the energy affordability and foster a green and just transition. IEA stands ready to advise and support countries along this path. Please contact us to receive more information on how IEA can support your country develop more solid energy price tracking systems that will support sound and effective policy choices. Thanks.
So now we are ready for question and answers, and I'm joined by Domenico Latanzio, who is the expert on energy prices and taxation at the IEA. And if you have any questions, do not hesitate to write in the Q&A box and let us know. We have one question in the chat box, which is, what are the impacts of having VAT in electricity prices to the consumers and to the utility?
Hi, I hope I'm Domenico Lattanzio, and yes, I'm responsible for energy prices at the IEA. Yeah, the first question is interesting. Of course, the experience of different countries is having VAT in energy taxation. Some countries decide not to have VAT for some energy commodity. For example, electricity in India doesn't have VAT. And what is the impact? Of course, the impact is on the side of the consumer, because this increases the price, increases by the amount of the VAT, of course. And for example, for OECD countries, you can have VAT which takes up the 20% of the total price, which is relevant. From the utility point of view, depending on the structure and the tax structure in your country, VAT might be refunded for industry. So, for example, in a normal, an average OECD country, VAT paid by the consumers then is balanced by the utility, and then the utility gives to the state only the share of VAT that is paid by consumers, deducted by the VAT that the utility is paying with the raw materials. So it's completely transparent for the utility if there is such a system in place. But of course, for consumers, has an impact.
Thanks, Domenico. Please take the opportunity that we have Domenico with us to ask any questions you might have. I think there's one in the Q&A box. Does IEA factor in the levelized cost of flexibility when comparing different sources of electricity generation?
Can you repeat the question?
Does the IEA factor in the levelized cost of flexibility when comparing different sources of electricity generation?
So basically what we do, we collect end-use prices. So we don't differentiate among different type of productions. because really the idea for us is to track what is the cost that the general user has whenever wants to connect to the grid, whenever wants to plug in his or her computer. So with that,
we can't hear you.
okay, can you?
Yeah.
Since the beginning, you couldn't hear.
No, now
okay.
It just cut off a few seconds.
So yeah, we don't differentiate between productions, and we want to know what is the price paid at the bill for the general user. Of course, the different mix of production affects the final price for the electricity, and we can see trends in the countries that are shifting from fossil fuels to renewables, for example. And of course, the price that we are collecting also is either a weekly, monthly, or yearly price. So you see this impact of the generation in the general level of the prices, but you see a lot this impact in the spot market, for example, depending on the generation of that time. But for this data collection, we see it only on average.
Thank you. There are 3 more questions. Could you repeat or expand further on your explanation on the tariff versus the price difference?
Yeah, sure. Of course, as mentioned before, the idea of this data collection is to assess how much a general consumer pays in the bill, if we are talking about electricity. Whenever we are talking about electricity, we have this problem in distinguishing tariffs from the real price, because for electricity, we can have different ways of charging the price for electricity. Of course, almost all the contracts across the world have 2 components, which are fixed charges and the variable charges. If we take into account only the tariff that covers only for the variable charges, we wouldn't miss the fixed charge part. And this might represent a lot of the total bill for the users in some countries. So our methodology is to calculate what is the general average price paid by the consumers, taking into account both fixed charges and the tariff. So as presented in the presentation, we have this, if we have a bill where we have, for example, 10 euros for the fixed charges and 10 euros for the variable charges, we would sum up the 2 components and divide by the energy used by these consumers. And this works for one consumers and works for all the consumers. So if you calculate the sum of the revenues from the utility and the quantity of energy sold to the users, and you divide those 2 numbers, you come up with what we call price, and not with the tariff, which is set generally by the authority.
Thanks, Domenico. We have other questions. Does X tax the same thing as excise tax? So
there are 2 different things. I mean, the names can be confusing. So X tax is anything that goes before the taxation. Basically is all the process that leads from, for example, if we are thinking about transport fuels, it's everything that takes from the crude oil, from the extraction to the transportation to the refining process, and to have the gasoline at the pump station. All those costs and margins that are based by the raw materials, like the transportation of the fuel and the refining of the fuel, all those costs that are linked to the supply chain, those are what we call X tax prices, which is exactly what is paid before the taxation. Then you have the excise taxation, which is this taxation that generally all the governments put on the energy commodities to raise revenues or to compensate for the pollution caused by those fuels. And this is really only a taxation. In general, is levied on the per volume basis. So it's €1, $1 per liter of gasoline, for example, and it's just taxation. So X tax is before the taxation, excise, it is the taxation. To those 2 components, then we have also the value-added taxes for the countries that decide to apply a value added to the energy commodities.
Thank you. We have another question. What is the best approach in tariff structure for distributed generation, seeing that the generation is close to the consumer?
This is a very wide and big question. It's very interesting to understand how different countries are dealing with it. It's really a matter of policy making. It's a matter of a policy decision. And there are some directions in Europe that goes toward facilitating this type of integration, for example, because it, whenever you facilitate and so you reduce taxation for those kind of users, you are also forcing the use of renewables for at the level of end users. But there are wide discussion, and this goes a bit beyond of our data collection here, but it's super interesting, and we are looking also at it with some IEA reports.
Thank you. One last question. What is the right excise duty and what is the right VAT? How are they determined to ensure fairness?
Another big question. I don't think, I mean, this is like my vision working with those data and with this matter. I don't think there is a right and a wrong approach. I think that the idea, it depends really from the country, depends on from the users. Of course, this is basic. We need to guarantee access to people, and we need to avoid energy poverty. I have wrote a commentary about that, about transport fuels, for example, and I would invite this participant to have a look at it. And I think the idea is to shelter the poor part of the population and try to raise revenues and put a taxation on the most rich part of the population to compensate. Of course, the first aim of a government should be energy accessibility. So this needs to be a priority. And then whenever this is affordable, then you can think about putting a taxation on it. But this is like really complex subject, and there is no such a right answer, right or wrong answer to this problem. It depends really on the country.
Thank you. We have time for a few more questions. Please write in the Q&A box if you have more questions for Domenico, and then we will move on to the exercise. I don't see any more questions, so let's move to the exercise now.
Maybe I see one in the chat. No,
you answered that one, no?
And there is another one just came, I think. The X-tax.
Oh yes, I did.
Component in gasoline prices consists of government taxes and levies. So how VAT is calculated to avoid double taxation? Actually, I wouldn't call it double taxation. I mean, but VAT is on top of the excise taxation. So of course, VAT is a percentage of the total price before VAT, which consists in next tax and excise. So you do apply VAT to the excise taxation most of the time. There are some few exceptions to this. Chile, for example, is one of them. But really, being the VAT something, a tax which gathers revenues, and so it's just a matter of the government. It's just a way of the government to raise revenues, and it's not such a big problem if you're applying VAT to the excise, which is already a taxation. It just increases the revenues of the state, of the government, and this for this reason you might have also like reduced VAT rates for few products, for example, to shelter the poor population from the energy poverty. Yes, the answer is that VAT in most of cases is applied also to the taxation.
Yeah. We have one question, I think, in the Q&A box. Okay, two now. Do operational costs of institutions handling energy and oil companies have to form part of the energy price? So operational cost for handling energy and oil companies.
I think that everything goes in the sum. So
Yeah.
if we have a state-owned oil company which is responsible for producing and for distributing the fuels, of course, the cost of this system goes into the final price, because the final price reflects both the efficiency of the production, the efficiency of the system that is also dealing with it. So it's an indirect way, as in any company in the world, not only for energy. But yes, of course, in the end, it goes into the prices. And this might be also the reason why the ex-tax price, which is the price before taxation, is different from country to country, because this depends on the availability of the raw materials, also the efficiency of the countries in producing the materials. For example, if we have a country where we don't have any refineries and we need to buy oil products, of course, there the ex-tax price, so the price before the taxation, is already higher than in the other countries. There was a good example, I think, was Mexico at some point, that was lacking of refineries. And then you see, really, whenever you don't have refineries, you might have an increase in price.
Thank you. So another question, what would be the best tariff approach in making electrification for rural communities of Sub-Saharan Africa sustainable, at the same time considering reduction in energy poverty through promotion of energy democracy?
It's like more philosophical, I think, as a question. I think, and this is my personal view, that renewables should play a central role in Sub-Saharan Africa, and right now costs went down and are still projected to stay low and go slightly down. So I think this is an opportunity to include rural centers and to produce something, and to replace, for example, the diesel generators that are not only polluting, but also they are expensive to maintain. And so I think renewable, coupled with this distributed generation, might be one of the answers to those problems, which are of course hard to address.
Yeah. There's another question. Does the IEA have models that can be used to determine fuel prices?
As we said during the presentation, if you are interested in having a look together at what you have and how this can be rationalized and maybe put in a database and structured as we do for many countries in the world, please don't hesitate to reach out to us. We can have a chat, have a meeting, a bilateral, and really happy to hear from you first, because we need to learn for your countries. For example, right now we don't have your country in the database. We do have some information on prices, but still we weren't able to capture what is in the country. So it is really useful to have a conversation with you, but also we can help to show you again, if necessary, our methodology and how other countries are doing in tracking those prices. So please don't hesitate to reach out to me by my email or by the general email, prices@iea.org, and we can have really a project, something, have a look at data together. We're really happy to help.
Yeah. Yeah, indeed. After the training, we will organize bilateral meetings with experts on energy prices in your country. So if you work on energy prices and you would like to share information with us and also learn from us, please get back to us by email so that when we organize the meetings, we make sure that you are involved and included in the exchanges. Yeah, I think I don't see more questions. Thank you. It was quite interesting, the exchanges during the Q&A. And please use the Q&A box to send us questions so that also all participants can see the questions. For the chat box, it's just sent to us. And so the others, the participants don't see them. And yeah, so put all your questions in the question and answer box. And now let's move to the exercise. So we have a small exercise on prices.
Thank you very much for the participants for the questions.
Yes, indeed.
Good
It's a good
exercises.
team. Yeah. Thanks, Domenico. So this was the exercise that we shared with you in advance. I hope that you have been able to practice and work on them. So now let's look at the solutions together. So the first one was, so here you can see some information for country A, for household, on taxes, and also data on industry consumption, and also for power plants. And then you will have to fill the tables here, the highlighted in yellow for household, industry, and power plants, based on the information on the left side. So the first question is, calculate the average gas price for household, industry, and electric utilities. And you have a few hints here, which is calculate the average total price for household as the value divided by the quantity, calculate the rest of the data, remembering that households do not pay excise taxes in this example, and calculate 2019 for industry and generation, electricity generation. So here you have the information here, and for example, let's start with taxes. You know that here there's a 20% VAT that is applied. And as we said, VAT is applied only to household. So here you put 20%. And we know that industries don't pay VAT. And same for electricity power plants. They don't pay VAT. So here it's 0%. And for excise tax, here you have the amount, which is 31.9 euro per megawatt hour in gross calorific value. So here you know that household do not pay excise tax, but industry, they do pay excise tax as well as electricity plants. But so now you have the information on the taxes and you can calculate the rest. So here for household, you can calculate the total price because you have the information on how much they spend for heating and cooking by gas in euro, and also the average consumption of natural gas in megawatt hour GCV. So here, the natural gas price for household in euro per megawatt hour, you take your average spending and you divide it by your consumption. So now you have the information on total price, you have also your VAT. So you can back calculate your ex-tax price based on that information. And once you have calculated your ex-tax price based on your total price and your VAT, you do a back calculation here. You can now calculate your total VAT amount, which is 20% of that amount. So your total tax is normally the sum of excise tax plus your VAT, but here excise tax is 0, so it's just the VAT amount. And So for household, you have everything filled out. Now let's do industry. For industry, you know, what do we know here? We have the revenue from industrial consumption, and here it's precise, excluding excise tax, which is 49.8 billion euro. And also you have the quantity of natural gas sold to industrial consumers, which is this amount in gigawatt GCV. So here, your ex-tax price, it's your revenue divided by the consumption, the amount of gas sold to industrial consumers. And here you have to adjust the unit. So here you multiply by 10 to the power of 6, because here you want euro per megawatt hour, and here it was in billion, and here it was in gigawatt hour. So here you get the amount of excise ex-tax price. You know your excise tax, you know that there's no VAT, so VAT amount is 0. And your total tax is just your excise tax, and your total price, it's the sum of your ex-tax price plus your total tax. Now for power plants here. So for power plants, we have the average purchase price of natural gas in 2015, excluding excise tax, which is, so this should be 2019, which is 735 euro per megawatt hour, but here it is in net calorific value. And the ratio of gross to net is 0.9. So here we had already put the excise tax in the beginning, and your ex-tax price, it's your average price, but here you adjust to put it back to gross calorific value. So here you multiply by this 0.9, so you adjust it, and your total tax is just your excise tax, and your total price, it's the sum of your ex-tax price and your total tax. So we have filled the 3 tables for prices, and now let's look at question 2. Calculate the growth rate of natural gas prices between 2010 and 2019. So here you do a simple growth rate of 2019 divided by 2010 minus 1, and you get an increase of 18% in nominal price. So can you say that prices increase since 2010? If not, how could you modify the price to have a better comparison in time? So here it's just a nominal growth, but it doesn't tell us clearly what has happened to the prices. Here, it doesn't take into account the inflation, so a deflator. And in this case, a CPI, a consumer price index, should be applied. As these are household prices, so we apply the consumer price index. So here what we will do is that we will recalculate the prices, but adjusted for inflation. So here what we do is that here you have the information on the CPI, and what you will do here is that you will take the price here for 2010 and you adjust it with the CPI, and this is the new price. And same for 2019, you take the price in 2019, you multiply it, you divide it by the CPI, and you get the adjusted price in for 2019. And if you calculate now the growth rate in 2015 dollars, because here your CPI is based 2015 is equal to 1, so this is the base year, and here you see that there is a decline in prices in real terms. So it's important that you take your this into account and not just do a simple growth rate that is misleading. I think so. That was all for this exercise. If you have any questions, you can let me know or write an email to me. Some participants have written to me on the balances exercise, so that was great, and we can see together your corrections. So for prices, we are done now, and we will now move to energy efficiency indicators. So in this second part of the training, we will look at why is it important to develop energy efficiency indicators, and what information is available, and also what further data you need to continue to track properly energy efficiency, and how do we collect this information. And there will also be an exercise session after. But before we start with the presentation, we will do some Menti question again. So here again, can you please connect to www.menti.com and use the code 7049, 34 and 04. So the first question is, what do you think when we speak about energy efficiency? What comes to your mind when we talk about energy efficiency? So it's an open-ended question here. You can write what comes to your mind. Reducing energy costs, using less energy, price reduction, energy savings, good. Minimal losses, high outputs, very good. Power factor, excellent. So what do you think when we speak about energy efficiency? Productive uses, excellent. So yes, less energy for same work, savings, very good. So let's minimal waste. This is very good. So we have a few words that explain well energy efficiency. Let's look at the next one now. Output, input, very good. Some interesting words. So the next question is, what is energy efficiency? So here you have 4 examples of energy efficiency. Is it to consume less energy to provide the same service? For example, if you use LED bulbs instead of incandescents. Is it to consume the same energy to provide more services? Example, you increase production of steel. Is it to consume less energy because of a change in service? For example, there's an economic restructuring from heavy industry to services. Is it to consume less energy and provide less service? Example, biking instead of driving. So what is energy efficiency? In these 4 examples. So here I think you can answer, it's you can have more than one good answers. So excellent. So let's look at the right answer. So there was 2 right answers here. It's to consume less energy to provide the same service, and also to consume the same energy but provide more service. Last question. Do you think energy intensity of the economy, which is the total energy supply divided by GDP, a good indicator of energy efficiency? Do you think energy intensity is a good indicator of energy efficiency? Many of you think that yes, it is a good indicator. And the right answer, it's no, it's not the ideal indicator for energy efficiency. To really analyze energy efficiency, we need to go one step further and look at more activity data and look really in more details to really see whether we are really having energy efficiency. But it's a good start to use energy intensity, but it's not the ideal one. So thank you for participating. And now let's move to the presentation.
So why energy efficiency is important, and why do we need energy efficiency indicators? Usually, when we think about energy efficiency and why it's necessary, we'll think about the reduction in energy consumption. However, there are many other benefits from energy efficiency. Here we can see what we call the energy efficiency flower, representing multiple benefits from energy efficiency improvement. Those benefits can be economic, social, environmental. For example, by increasing employment, increasing energy security, or by reducing harmful emissions. This is why many countries have set energy efficiency targets, and this is why it's important to have end-use data to track the progress of energy efficiency policies and to be able to set the correct target for those policies. Here we can see policy design examples, but also benchmarking exercises, which are an important application of this kind of data. However, there is still a very high portion of energy consumption that is not covered by energy efficiency policies, and this represents a large potential for action. Only 35% of the global energy consumption is subject to mandatory efficiency standards. And it's estimated that in Africa, only 2% of energy demand is covered by energy efficiency policies. This is why it's very important to have detailed data in order to be able to study energy efficiency trends in depth, to know the priority areas and where we stand, to set the targets, and to track and monitor the actions. But now, let's see what kind of data are already available from the energy balances. Energy balances give a very useful piece of information, and combined with some macroeconomic data, allows to calculate aggregated indicators, like for example, the energy intensity. However, there are limitations in terms of the disaggregation of the data. For example, in an energy balance, the residential and the services sector are represented as total, while in order to study energy efficiency, we would need a further disaggregation by end use. For example, space cooling and space heating. One of the possible starting points to identify priorities in the breakdown of final energy consumption by sector. Usually this information can be easily extracted from the energy balance of a country. So, for example, in this case, we can identify that the residential sector is the most consuming, so it's likely to be considered a priority sector for energy savings. However, we need more detailed data to better assess this, like for example, the consumption by end use, such as cooking, water heating, or space cooling, and the related activity data, like number of occupied dwellings or surface. Not having proper data could lead to wrong policy decisions and actions. Let's see now an example of widely used, the energy intensity. We can see a figure illustrating the energy intensity trends for different regions since 2000 to 2018. Energy intensity is commonly used as a proxy for energy efficiency. However, the indicator is too high level and includes different factors, such as the structure of an economy or the activity, besides real efficiency. So in order to study efficiency, we need more detailed data. Let's see another example where we study the residential sector trends, starting by using the most aggregated data to using the most detailed one. If we analyze the residential consumption over 20 years, shown in the graph in the blue line, we see that there has been an increase as a whole, plus 15%. However, we can see that the consumption per capita, the red line, is at the same levels at the end of the period, more or less. If we go to the more detailed data indicators, for example, the consumption of energy for space heating divided by occupied dwellings or by floor area, we can see a dramatic reduction over the analyzed period. So this means that even if residential energy consumption increased and residential consumption per capita did more or less remain stable, important efficiency improvements are witnessed in space heating. The residential per capita indicator did not show any change even with the big efficiency improvements in some end uses, probably because of the increased use of new appliances, such as smartphones, computers, tablets. So all in all, it is essential to choose the most appropriate indicator depending on what do we want to observe. If we just look at the total residential energy consumption, we would observe that the total final energy consumption has increased by 15%. However, this does not mean that we are less efficient now. For instance, the residential space heating energy consumption per floor area has decreased 35%. So it's really important to choose the proper indicator depending on the message we want to give and what we want to observe. So what drives energy intensity then? The efficiency progress is one of the drivers. For example, more efficient industrial processes will contribute to a lower overall intensity. But there are also other factors like the increase of the activity, for example, the increase of population, more houses, more cars, or the structural change of an economy. For example, a country switching from the industry to the service sector, which is less energy intensive, that also affect the energy intensity. So it's really important to differentiate which improvements come from improvement in energy efficiency to track the impact of energy efficiency policies. Here, for example, we can see how energy efficiency helps to decrease the overall energy consumption, while the increase in the activity contributes to the opposite. So, what additional data are needed in order to study energy efficiency? As we have seen from the energy balances information, we can create some energy indicators such as the total final consumption per population. However, those indicators are not specific enough to monitor energy efficiency. In order to study energy efficiency and obtain energy efficiency indicators, we need end-use data or even more disaggregated data. However, the greater the disaggregation, the more data are needed, and usually this also comes with higher cost. Collecting data is costly, but enables a better design, monitoring, and evaluation of policy. Not having proper data could lead, as we said before, to incorrect decisions and actions, and as a consequence, to even higher costs. Also, in order to develop indicators, apart from energy consumption data, it is essential to also collect activity data. The activity data are sector specific. It could be a physical production of a certain commodity like cement or steel, floor area, or the distance driven by a vehicle. Combining energy consumption and activity data, we can obtain efficiency indicators that explain how much energy is needed to provide a certain service. For instance, how much energy is needed to produce a ton of steel. Let's now see which data we can collect for every sector. And let's start with the residential sector. In order to calculate energy efficiency indicators for the residential sector, the IEA recommends collecting energy consumption data by end use. So, for example, space heating and cooling, water heating, cooking, lighting, as well as energy consumption of different appliances, such as dishwashers or televisions. It's also important to collect data on heating degree days and cooling degree days in order to be able to correct space heating and space cooling energy consumption for the year-to-year variation of the temperature. In other words, when we analyze energy efficiency indicators for space heating and space cooling, we want to observe change in the energy consumption resulting from the energy efficiency improvements and not from the climate effect over this consumption. If the winter is harder, then it's very likely that people are going to consume more energy for space heating, for example. And we want to avoid this effect. Regarding the activity data for the residential sector, we could collect information on the number of dwellings, particularly occupied dwellings, residential floor area, as well as stocks of different types of appliances. We should also pay attention to the activity data we use for our indicators. For example, if we use total dwellings, we will also account for abandoned dwellings and secondary residences. Therefore, in order to avoid counting in efficiency empty buildings which does not consume, we should exclude vacation homes and unoccupied dwellings. And so this way we keep the same boundaries between the energy consumption and the activity related to this energy consumption. Let's now have a look at what we can do in terms of data collection for the service sector. For energy, we can also collect data by end use. So, for example, space heating and cooling, lighting, other energy uses in service buildings, and also non-building energy use, for example, street lighting. We can also collect electricity and other fuel consumption data and floor area by IC categories instead of by end use. But it's also good to do for both end use and IC categories. And the most relevant activity data would be the value added, the floor area, or the number of employees, for example. The next sector is industry, and for energy, in the IEA, we collect data for 19 major ISIC subsectors. And when it's possible, we encourage more detailed data collections. For example, energy consumed to produce aluminum or cement, since this data collection allows for physical indicators that are more detailed than the major ISIC categories. And when it comes to activity data, we focus on the value added created by a given subsector. But for certain energy-intensive and homogeneous industries like paper and iron steel, we can collect also the data on the physical production, such as the tons of steel produced. And finally, the transport sector. It might seem a little bit more complicated than the other sectors because here we differentiate between transport segments and modes. So segments include passenger and freight transport, while modes refer to road, rail, air, and water. Regarding the activity for the transport sector, we want to observe how much and how far we can move. So for instance, how many passenger or tons of goods we can move and how far. To measure this, we use vehicle stocks, vehicle kilometers, passenger kilometers, ton kilometers, and we calculate passenger kilometers and ton kilometers as the total distance traveled by all the vehicle stocks that we are analyzing, multiplied by the occupancy for passenger transport or by the load factor in case of the freight transport. But how can we collect all this data we are mentioning? So in 2009, the IEA members countries agreed on the new energy efficiency indicators data collection. Thanks to the cooperation with international experts, an Excel template was developed, and you can find this template already in the IEA website. And with this template, the IEA collects both energy and activity data for all the four sectors presented: residential, services, industry, and transport. In December, we published the energy efficiency indicators database and a report called Energy Efficiency Indicators Highlight, where we include all the countries that collaborate with us, not only members. We are open to collaborate with any country that would like to do so. And this report, of course, is also available online free of charge. And on top of that, the IEA has also cooperated with AFREC to develop a questionnaire for energy efficiency, particularly for the residential sector. So on the country level, the IEA differentiates four main data collection methods. And firstly, before starting any new data collection, it's good to make sure that this data is not already collected. So for instance, if you need some activity data for transport sector, it is possible that the Ministry of Transport is already has this data. So it's very important to map where all the data that I need might be located. If you're sure that these data are not available, you can start your own data collection by launching, for example, a new survey, or you can even decide for a less expensive options, which could be expanding an already existing survey. For example, adding some transport questions on a household surveys. Another method is metering and measuring. That is relatively costly, but really effective if you want to measure efficiency of some specific equipment. And here we can also find, for example, smart meters, which are more and more used nowadays. And we also have modeling, which is the last of the four methods, and it can be complementary to surveys and metering or used standalone. For instance, by using activity data and total energy consumption data from the energy balances as input to estimate energy consumption by end use, for example. The IEA has developed two manuals. The first one is the Fundamentals on Statistics and provides guidance on how to collect data and how to develop those efficiency indicators. and it includes also a compilation of existing practices of data collection from across the world. And the second one is the Essentials for Policymakers, which advise on how to develop those indicators as well, and particularly how to interpret the energy efficiency indicators. Both manuals are available on the IEA website in English, Spanish, Russian, Chinese, and also French. Before starting any data collection, it's always useful to have a look at what other countries have done. For this purpose, the IEA developed the country practice database, which is a very useful resource to learn from each other. It's a very powerful tool worth consulting before undertaking any new data collection, because it allows seeing what other countries did and to take an advantage of their experience. For example, if you are planning to develop a new data collection, such as a new household survey, for example, you can check what other countries have done and even the details of that survey, the results, and even the questionnaire of that survey. And also, if you have a country practice that you wish to share, please contact us so we can make it available for others and others can benefit from your expertise. I would like to conclude with some key messages. First of all, detailed energy and activity end-use data are crucial for well-informed and effective policies. These data are essential for identifying priority sectors and understanding energy efficiency trends and monitoring policy effectiveness. Therefore, it's extremely important to raise people's awareness of the detailed data needs and underline benefits of country-specific data collection and analysis. It's also important to benefit from the experience of other countries and organizations, as well as contributing to this. So we invite all countries that want to start collaborating with us on end-use data and efficiency indicators to reach out, and we can discuss in more detail the potential collaborations we could develop with you.
Sorry, I was on mute. Yes, I was saying that I'm joined by my colleague, Victor Garcia, who is an expert on energy efficiency indicators. And please send us your questions in the Q&A box. Hello, Victor.
Hello, can you hear me properly?
Yes.
Perfect.
So there are 2 questions already in the Q&A box. Maybe you can start with those.
Yeah, sure. Well, as you already know, I'm responsible for end-use data collection and development of energy efficiency indicators. I'm very happy to be here. So please send us all the questions you might have about the presentation or the exercise or whatever. And yeah, let's start with those questions. And the first one is, what effective method can be used to collect disaggregated data on energy end use? This one, actually, when you wrote it, the next slide was summarizing some of the methodologies that we consider in the IEA for the collection of end use. And the answer is, it depends on the end use data you are collecting. So mainly depends on the sector, for example. But it's a good practice, as we were discussing at the end of the presentation, to see what other countries have done before. So for example, if we want to collect some end-use data from the residential sector, it's a very good practice to check what other countries did, for example, designing a survey. And for this, the IEA has the country practice database, where you can actually see what other countries did, and you can even find some survey designs. And then the other very good practice for this is to check if this data has been already collected. So for example, if you want to find some activity data for the transport sector, like passenger kilometers or stock of vehicles, it's very good practice to check, for example, the Ministry of Transports or any other institution, like the transport registry or the technical inspection of the vehicles, because they can have all this data already. Of course, if the answer is not clear, please feel free to ask again.
Yeah.
Okay, I'll move to the second one, and then it's how do you track the passenger kilometer when collecting transport-related data for efficiency? So passenger kilometer, there are several ways to collect it. It's common, for example, that there are some countries that collect it either in gas stations, or they can even expand the household survey. Like for example, asking some questions to the people: how many trips you do per day, how many people are in the car, how long those distances are, and then they collect all this survey data. And another way you can do this is, for example, by modeling. You can actually combine both methodologies, and then you can estimate how many, for example, if you have a stock of cars and you know more or less the average distance traveled by those cars, you have already the vehicle kilometer. If then you multiply by the load factor, in this case, how many people are by car, then you can obtain the passenger kilometer, and then you'll have an estimation of the passenger kilometer for your country.
Thanks, Victor.
Okay, again, if not clear, please send as many questions as you want. But I'm going to move to the next one. When assessing the efficiency for space heating and cooling, how do you compare extreme cold and extreme hot locations? I know extreme weather affects the efficiency, COP of appliances, heat pumps. That's a really good question. And this is one of the reasons why energy intensity, for example, it's not a good measure of energy efficiency, because the factor of the climate is not contemplated, let's say. So how do we work around this is by correcting the energy consumption of, for example, space heating or space cooling. And one way we do this is we collect heating degree days or cooling degree days. That what they do is they are a measure of, for example, how cold was a year, or how warm was a year. And with this data, we can actually correct this energy consumption, so we can have these international comparisons you are referring to. So we try to avoid the effect of the climate, because what we are really interested in is to measure the efficiency, or if we are actually, for example, doing space heating efficiently. We are not interested in if we are consuming more because the winter is harder, because this is okay. So it's okay that people want to consume more if the winter is harder, but we want to do it efficiently. And for that, we want to avoid the noise that the climate creates, as you were mentioning. And this relates very well with the next question. This stands for heating degree days and cooling degree days. And indeed, this is some data that it's used for climate correction. And in fact, in case of interest, the IEA developed the weather tracker, where you can find heating degree days and cooling degree days for free with a global coverage. So you only have to look for IEA global weather tracker, and then you can find it there. Maybe we can post the link somewhere.
Yeah, that would be great. So please send us your questions. We have a bit more time for question and answers, and let's take advantage of having Victor with us.
I have it here.
Maybe if there are no questions, maybe we can ask if you can write down what type of energy efficiency work is being done in your country, because again, like for prices, we will do bilateral meetings on energy efficiency indicators, and we are interested in knowing what you are currently developing in the country, what kind of data you are producing, and yes, if you're working on this and would be interested in joining and being part of in those meetings that we will organize soon after the training, please let us know by email, and we'll make sure that you are part of this project that will start soon. No more questions?
Would you like me to develop more in any of the questions you sent before?
Yeah.
Please let us know. And as Saki was saying, very happy to receive any questions by email or any proposal for collaborating with you. We are always open to talk with you and discuss your particular situation.
I think it's really interesting, this database where countries share practices and you can really learn from it. So if you have not yet had the chance to take a look, I think it's a good place to go and see and learn from what other countries are doing. You can get good ideas and see how you can learn from their experience.
Yeah, it's actually quite interesting because you can actually see what the countries did in detail. So you can find the actual questionnaires, for example, that were used in a survey, what was the response rate, what the country was actually trying to measure, like energy per household, or the passenger kilometer, for example, like the question we had before, how to measure this passenger kilometer. You can type down there passenger kilometer, and then you'll be referred to all the countries that tried to measure there and what was the methodology behind. So that could be a really good complement to your question.
Yeah, it's quite a powerful tool, I think.
Mm.
Well, if there's no more questions, then we can move on to the there's one question that arrived. So the question is, what's your take on impact of weather on electrical infrastructure? Do we envision the need to have climate resilient infrastructure? I make reference to what transpired in the United States when people had no electricity due to cold weather.
Well, this goes a little beyond to the scope of the energy efficiency indicators, but indeed the weather, it's very related with energy consumption, particularly with space heating and space cooling. And here, what I can talk about, my expertise is that it's very important to differentiate all those factors within the energy intensity. So it's really important to differentiate the energy consumption that is related to the climate, to the, for example, cold winters or very warm summers, to the, let's say, the actual regular consumption. About the intakes, I'm afraid I'm not in a position to answer.
The link to the database, I think you will post it
Yes,
in the Q&A box.
In the Q&A or in the all panelists, what's your preferred approach?
Maybe not, because panelists only us will see.
Okay. The chat I want, okay.
unless, yeah.
I'll put it right there.
Yeah. Yes, if you choose all panelists and attendees, then maybe they
Okay.
can see it as well. Maybe post it in both so that
Wonderful.
we are sure everyone sees.
So this is the weather database. Also, related to your question about the weather, I recall now that there is a very interesting article related to this in the IEA webpage. I'll try to find the link and put it there. And there you will find people that's actually expert in this topic talking about it from the IEA. From our side, what we can emphasize that it's really important to actually make those climate corrections to actually get those insights.
There's a last question on what does the IEA consider as standard energy efficient design codes for buildings?
Well, I guess you are referring, for example, to standard energy efficiency design code for building. Okay, we have also a really good article about building envelopes and standard efficiency design codes. I will refer to as well, but we don't really have a consideration about this. So we explore all the countries, what they do, which are the, for example, also minimum standard performance so the different policies that are in place and measures for energy efficiency in the different countries. We don't impose a standard, for example.
Yeah.
Let me check for this database.
We can take a few more questions if you have any before we move to the exercise. So in the chat box, Victor is putting the different links. So normally you can see them.
So far you have the energy tracker, the climate and the weather for energy tracker, the country practice database link, and I'll search for the links to the weather and the USA case, and also for the building envelopes and standard codes.
There are two more questions, Victor. Maybe while we do the exercises, you can put the different links in the chat box, and we move on with the questions instead.
Sure.
So there's do you use net zero buildings as benchmark in energy efficiency performance in dwellings?
I'm not sure what you are referring to exactly. Do you have ideas, Akia?
No, I'm not an expert in buildings. Maybe we can check this one with colleagues and reply to Joshua. I have his email and we can get back.
Where I can talk about is in the building sector, in the residential, and also in the service sector. What we do is we collect end-use data and also by IC category in the service sector. And what we do is we collect all this end-use data like space heating, space cooling, and then we couple this with activity data, like for example, floor area, occupied dwellings, number of employees as well. And we develop all those indicators. And then you can benchmark one country against the other, but we don't necessarily start from net zero buildings, or we go to that level of detail. So what we do is we collect data and we develop indicators about it that then it can be used for benchmarking, but this is not an exercise we do, at least not in energy efficiency indicators data collection.
Thanks. So the next question is, how does Africa compare with other regions when it comes to energy consumption per floor area of buildings?
This is a tricky question, in fact, because we don't have that detailed data for the region yet. And this is why it's so important to collect this data, because actually the residential consumption in Africa, it's really, really important. It's one of the main priorities to tackle. And it would be really interesting to know not only the energy consumption of cooking, of space cooling, or all those residential end uses, but also the floor area. So it's really, this is to emphasize that it's both important to know the consumption data, but also the activity data to couple with it. So I would love to be able to answer this question, but unfortunately we don't have this level of disaggregated data by the moment.
Thanks. There's another one. What is the impact of distributed generation on energy intensity of a country?
Well, the only impact I can think of from the statistics point of view is that distributed generation is a little bit more complicated to track. So it could have an impact that you could overestimate it or underestimate it, but the denominator is going to be the same, that it's the GDP. So in principle, it doesn't necessarily have an impact to it. The only effect from the statistic points of view I can think of is that distributed generation, it's harder to track than when you have a centralized generation and everything is reported, so you have a more accurate measure of the energy consumption, let's say.
Okay. I think that was the last question, and maybe now we can move to the exercise session, and you can still put the other links that we talk about in the chat box so that the attendees can get access to them. Thanks, Victor.
Of course, thank you to you.
Now I will, yeah.
No, of course, reach us whenever you want, and please go ahead with the exercises. I hope you enjoy, and yes, yeah. Thank you very much.
So now let's look at the energy efficiency exercise solution. So for this one, you had a simplified energy balance for the year 2019. And you had a few questions based on this balance. And the first one was calculate the energy intensity for the country. And you're given the GDP information. So energy intensity of an economy, it's calculated as the energy required to produce 1 unit of GDP. So you take the total energy supply and you divide it by your country's GDP. So you take this number, you divide by this number, and you get your energy intensity in megajoules per 2015 PPP US dollars 2019. And for you also now you're provided with the information for 2010, which is 7.8. And the second question is, did energy intensity decrease since 2010? If yes, can you say whether this is due to an improvement in energy efficiency? So indeed, the energy efficiency is lower in 2019 compared to 2010, but we cannot know exactly just by looking at this energy intensity numbers whether this is due to an improvement in energy intensity, the energy efficiency, because energy intensity, it's an aggregated indicator and it doesn't allow us to know in details. So a decrease here could be due to many reasons. It can be due to an economical shift in towards higher share of less intensive industries and services in the economy. So we really need additional disaggregated energy and activity data for all sectors and subsectors or end users in order to analyze well the energy efficiency. The question 3 is about, so here you are provided with some activity data for iron and steel, cement, industry, and also some value added. And you are asked to calculate the best energy efficiency indicator for those sectors here. So for iron and steel, cement, machinery, other manufacturing. So for iron and steel, here we have production information. And since we have that physical production data, it's the preferred efficiency to use. So here it will be gigajoule per ton, and the preferred in the calculated value would be, so here for iron and steel, you have the consumption, the total consumption, and you would divide it by your production. So that would be the preferred indicator. For cement as well, you have cement production, and the preferred indicator would be cement consumption divided by cement production. However, for machinery, we don't have production information, so we need to use value added, which is related to revenues, and in a certain way it's linked to production as well. So in many heterogeneous sector with less quantifiable products or that carries many different products, example mining, the value added is the preferred option because there is not a single physical product to quantify. However, using value added for efficiency indicators, it brings a certain noise because of the possibility of having different prices. So how much does 1 ton of oil, 1 ton of my product value in a specific market, for example? So when comparing the energy efficiency calculated with the value added over the different years, it's very important to use constant prices value added to remove that inflation noise. So if we go back here for machinery, energy intensity, here we have the machinery value added and we have the machinery consumption. So here you would take your consumption and you would divide by the machinery value added. And same for other manufacturing energy intensity. Here, other manufacturing here, you would also take your consumption divided by your value added. Now, same for industry, iron and steel and cement. So for total industry, you take your total industry consumption, you divide it by your value added. Same here for iron and steel energy intensity in that unit. Here you're already given the unit, which is per value added. So you calculate the same thing, and same for cement. The last question is, you are provided with the energy efficiency indicators based on value added for those 2 years. And it's asked to calculate the average annual growth rate for each of the sectors. So here we are calculating a compound average growth rate. So here you take your value in 2019, you divide it by your value in 2010, and you put it to the power of 1 divided by 2019 minus 2010, which is the number of years, and you get a compound average growth rate of -2% for iron and steel. Same for cement and clinker. You make this average, the compound average growth rates, and for machinery and for other manufacturing. And here what you see is that all sectors except cement is witnessing a decrease in energy efficiency. And this is probably for the other sectors due to efficiency improvement. That is, for example, a retrofit of existing plants or the beginning of operation of new or more efficient plants. However, for cement sector, there is an increase in energy intensity, and this could be due to maybe aging of plants, but also of other factors such as, for example, the country might have been previously importing more clinker, which is the raw material to produce cement, and is now producing it in the country, and this could increase the energy demand for its production. For other manufacturing sector, as we don't have more specification, it could include many different sectors. So a big shift in structure, that is a change in the mix of the subsectors that are part of the other manufacturing, it could be affecting the energy intensity of the sector. So that was the exercise on energy efficiency indicators. Again, I really recommend that you take the time and review the exercise, and you can use also the handbook that has all these answers to the solution to better understand a bit about the different indicators that that we are calculating. I see that Victor has been sharing the different information. There's a last question. In our country, we have challenges in having production figures or value added of various industry subsectors, such as iron and steel, cement, etc. But IEA provides energy consumption figures of these subsectors. Does the IEA use modeling to get the energy consumption figures? Would you like to answer this one, Victor? Yeah.
Yeah, no problem. Regarding the activity data, I'm aware the IEA gets a lot of this production data from industrial associations. Like, for example, you can get a lot of output production of iron and steel, for example, from the World Steel Association. So I'm aware this is a big source for the IEA for industrial production. And regarding the energy consumption, it really depends on the country. Because, for example, for the subsector, industrial subsectors, it's already in the energy balances. So if the country has an energy balance, it will probably have as well energy consumption for iron and steel or for chemicals, for example. So most likely the source of the energy consumption are the same energy balances.
Yeah, for energy consumption, most of the time it comes from the energy balances, and for production information, usually we do collect some information from some other sources, such as World Steel Association and other sources where we get those in data. For value added also, we get data from other sources. I think, is it UNSD?
Probably for, yes.
Yeah, there are a few sources, yeah.
If it's not an OECD country, probably it's coming from UNSD as well, yeah. And
yeah.
Sometimes those figures are estimates as well. So it's not always a direct data collection, but usually we use data from those sources, yes.
Yes. So by putting together all these informations, then we are able to come out with such indicators. Do you have more questions? We have a few minutes left before the end of the session. Otherwise, we can close it if there's no question that arrives. No questions for Victor. Again, please do not hesitate to write to us if you have questions on the exercise. when practicing them, or if you want to learn more on and participate in the bilateral meetings that we will organize for Zambia. And also, if you have information on energy efficiency indicators, if you're working on the topic and would like to share your work with us, and we would be happy to receive and discuss on this with you soon. Well, no questions. So thank you very much for listening to us for the past 2 hours. I hope that this last session on statistics on prices and energy efficiency indicators has been interesting and useful to you for your work. And there's one last question that just arrived. Is energy intensity always calculated in US dollars? I see that the index used is US PPP. Can it be calculated in a local currency, and what index would you recommend?
We usually put everything together to USD, in particular USD PPP, because the PPP, the purchase parity, what it guarantees is that we can compare the same levels across countries. So this guarantees an international comparison.
Exactly.
But of course, it's totally possible to do those indicators with the local currency. What we would recommend is to make it with constant prices, so that you differentiate between the volumes and the prices. So when it varies across the years, it doesn't reflect the variation of the inflation. So we really recommend to use these constant prices, so you pay attention only on the volumes. That's our recommendation.
Yeah, exactly. It's true that at the IEA, since our aim is also to have comparable data for countries, that's a value added for us. So that's why we usually produce information in US dollars and PPP. It's very important as well. So yeah, thank you everyone. And so we end up this part of the training on statistics. Tomorrow you will start with Arnaud. So I will not be here, but it will be Arnaud that will take over and lead the modeling sessions. And thanks again, Victor, for joining today. And have a nice day, everyone. Bye-bye.
Bye. Thank you very much.